So I have this fancy German keyboard, and it's a DOS keyboard actually, and I've had it for quite a long time, 4 or 5 years. So it's accumulated, quite a lot of stuff. So I had an issue where one of the keys was sticking, and I was using the keyboard, so I dropped a dab of lubricant down here, and it solved the issue. But now the button doesn't really work very reliably. I guess I got I changed the continuity of the contacts or something. So I need to take this button out. But I took one key off, and I saw how dirty it was. So I took all the keys off now. Now cleaning this is actually kind of hard. Because you'll notice, like, there isn't just crumbs and stuff. There is hair and other things. And if you take just like typical like electric component cleaning aerosol, this really doesn't work very well. The hair and stuff is all still in there. So what I'm going to be using is a little bit bigger. So I'm just going to be taking this and just running this down through here, and we'll see how that works. So I made a few passes with the drill, and you can see it actually started to take off the paint in some spots. But for the most part, at least, all of the hair is gone and all of that crap. And I ended up having to use a pick as well, and even try wetting the area in between the buttons, then going in between each and every one and getting the crap out. And you can actually remove these, but that would take forever. So I'm not going to do that. It's clean enough, I think. So now we can go through and then see what's wrong with our W button. So to actually remove the button and inspect it, we will have to desolder it from the board. Luckily, all the buttons are lettered with silkscreen, so the W button is right here. And I'm just using some wires to suck up the solder. But and we have one left. Okay. So you can see now, oh dear, the solder has been removed from those leads, these 3 leads here. And there we are, our W button. Focus, please, focus. So you can see these 2 leads here are for carrying the current to the switch. And let's see if we can take the switch apart before ordering a new one. So we have the broken switch apart now, and just as a demonstration, how these work is, there's a spring in the center, and then there's a plastic piece that the key mounts on. Now, this will focus. Please focus. I guess it's just not going to focus. So what happens is when you press down this switch, there isn't metal directly under the plastic. The contacts aren't directly under the plastic. They're actually next to it, right? So camera isn't focusing, but what's essentially happening is when you press on the switch, it's moving these contacts sideways. So just to get a benchmark, we can. I actually don't have a good multimeter around me right now, which is unfortunate. But we can actuate this switch because I removed another one from the keyboard just to get this benchmark. You can see that it's that's not right. That was just different. Should be about 1.5 ohms. One moment. Let's see. I'll try that again. One ohm. Which seems like not right. And then we do it again. Actually, wait a second. I don't know if how this how this actually works. Let's see. So when these are closed, it's about 1 ohm resistance. So there isn't. These are pretty good switches, it seems. Because the only difference between these actually being connected and the switch being actuated is 0.10 ohm. Is that mega ohms? I don't know. This is a very poor measuring instrument. But then we can compare that with this guy here, with our W key. And that's it not being on, which is interesting. So I'll try to put this back together here, at least momentarily. Get it? Because it's a momentary switch. So I'll put this in, and okay, I see now. So I must have fixed the issue when I was playing with it. So I'll clean off the contacts a little bit more and put it back together. But yeah, it's reading the same as the other switches, and that is the W key, right? Yeah. So we'll see if that works. So I don't think I'm going to be able to repair this switch just because they're so fragile. I thought I would take this as an opportunity just to show how these switches work. So in here you can see the gold-plated contacts, and I've bent this up. But how it would work normally is this would be bent down inside the switch, and when the plastic switch is in the resting position, when your key isn't on, when your finger isn't on the key, the switch is sitting in such a position that it's pushing this metal contact away from the other contact here. And when you press it down, it presses on these little tabs, and then that opens it just ever so slightly. And I've been fiddling with this and trying to get it in the right shape, but yeah, it's probably not going to happen. The key switch is about $2, so I'll probably just steal a switch from someone else on the keyboard and wait for replacement in the mail. So I was able to actually get the switch working again just by reforming the metal, but oh, I accidentally triggered the sensor again. But it's, I mean, yeah, see, 1 ohm. So it's kind of sketchy. So what I'll do is I'll just throw the switch in, like for like the print key or something that I don't ever use, and I'll just put a good key where this key would have gone. So the keyboard is back together now. I went through and I cleaned every key and put them back in. I had to cannibalize the scroll lock switch for the W key for now. But that's pretty much it. It should work. It was real easy, just tedious. The hardest part was not mixing up the keys.